Okay, what I want to do in the rest of the lecture is one final example, and it's a standalone example. Let me just compile this. So here's a program that I'm compiling. So I'm compiling it to a standalone instruction, which I can run. And it's the Hangman game, where you have a sequence of characters you've got to guess, and the characters form a word, in this case a dictionary word. So I can guess some characters. Let me guess S, T, and E, the most popular letters, only it's got an E in it, and I've burnt 2 of my, or 3 of my lives there. Let me guess H, A, O, I, N maybe. T, oh, I've done T already. Okay, that didn't use up a guess. L, anybody? F's a good one. No, not so good. Z? You're kidding me. Oh, C, sorry. The word was inrigged. One of those everyday words. Okay, so the task now is to actually define this thing, and I've got a file that I've started here, and it's not very big. So you notice that I compiled that into a standalone program. A standalone program in Haskell is the result of running a function called main. So if you want to have a standalone program that you can compile and run as a standalone program, it has to contain a function main. That will be the thing that's run. And the type of main will be something which has type IO of nothing. If it doesn't produce any result, its only job is to interact with the outside world. Okay, in this case, it's interacting with the dictionary file that's stored on the computer and me who is inputting characters. And then it outputs to the standard output. So no fancy graphics or anything, but it's a basic example of a program with IO. This is where I got the dictionary on my computer. Of course, this is dependent on which machine you're on. There'll be something similar somewhere on a Linux system. I don't know about Windows where you would find something like this, but there's probably some list of words somewhere. And I put in here, let's have a guess limit of 10 guesses, or 12, whatever, it doesn't matter, not too important. I'm predicting I'm going to use some functions from the list collection. I've already imported those. So let's actually start defining this thing. So what is this main going to do? Well, it's a game that consists of picking a random word from the dictionary and then basically playing the game. Okay, so there are 2 phases to the game. Selection of the word and playing the game. Okay, so this is basically going to split our operation into 2 parts. We're going to select a word. Let's call that random word for the sake of argument. This is going to be an operation which will interact with the operating system to firstly get a source of randomness, and using that source of randomness, pick a random word from this dictionary. Okay, so there's various interactions going on. So this will be an IO thing, but this will be an IO thing that will result in a string. Okay, so this will result in a word. Let's call it W. So this is a computation we will define shortly for producing a random word. Now, given the random word, we're going to start playing the game. So a game is a repeated process, right? It's an iteration, it's a loop. Any game is a loop. What state do we need to know at any point in the game? At any point in the game, we need to know what the word is that we're trying to guess, and we need to know the sequence of characters that we've guessed so far. Okay? Given those 2 pieces of information, that's all we need to calculate everything we need to know and everything we need to display in the game. We can work out if we've got any lives left. We can work out what to display. So they're the 2 pieces of information that we need. So what I'm going to do then is run a game loop. And the game loop will maintain those 2 pieces of information, namely the word and the guesses so far. So how many guesses are there so far when we start the game? There are no guesses at all. I'm going to use a string to represent the characters that I've guessed so far. So the initial guess will be, the guesses so far when we begin the game will be the empty string. Okay? Okay, so random word will be something of type IO of string. That would generate the, let's just write in a random word function for now. Let's say that this is not so random. So there's the random word. I just randomly chose it, so it's pretty random. I'm not sure this game's ready for production yet, but we'll get there. And the game loop, what's the type of a game loop? Well, it takes the word and a string, which is the guesses so far, and does our IO. Okay, so game loop is the main engine of the game. And what will the game loop look like? Well, it will have a word, and it will have a list of guesses that have been done so far. And there are three things that the game loop can do. It can decide you've won the game. Hooray. Fireworks. It can decide you've lost the game. Maybe it'll tell you what the word was, as it did in the example I just gave you. Or the third case is the case where we sort of really do the work, and that is where we get a new guess from the player. We show them the progress so far, and we continue the game. So there are three cases: winning, losing, and basically the rest, which is playing. Okay? So we can break that down into three cases. If we win, we're going to display some winning whatever. If we lose, we're going to show some losing stuff. Otherwise, we're going to actually play a round of the game. Okay? So all these are things which I haven't defined yet. I'm going to define them shortly. But they will all depend on W and G. They are all that I need to decide whether I've won or lost. Okay, in the case when I have not won and not lost yet, I've still got some guesses left. What am I going to do? Well, I'm going to display the status and then, so this is going to be a sequence of interactions. I'm going to display the status, start this down here. Then I'm going to get a word from the user. So let's say I get some guesses from the user. Where am I going to get the guesses from? I need some way of getting something from the input. There is a function called readLine. There's a function called getLine. I'll edit that out later. Which produces an IO string. So this gets the next line from the input stream. Okay. So it interacts with me and gets the next line that I type and returns that as a string. So I'm going to do a get line to get my next guess. And after I've done my next guess, I'm going to go continue with the game. And continuing the game means going back into the game loop with the same word, but now I have some more guesses as a first approximation of what we could do. We could add the guesses that we've just made to the guesses that we already had. Okay, let me just finish this, fill in this so we can actually run it. Let's just say we don't win or lose at the moment. We need to define show win. Let's make these all local definitions. That's rather important actually for the moment, so let's make this in a where. These are all local definitions. So why are local definitions important here? They're important because I'm going to use in the definition of these things the parameters W and G. Because these are all defined with one pattern, W and G, I can use W and G in the local definitions. So I don't have to pass them in as parameters. I'm going to show win. Okay. And show lose is also going to be undefined for the moment. Display status. Okay, let me just say just quickly. What is it? What do you when you want to print something on the screen? If we want to display a string on the screen, there's a function to do that. We saw the function print, but actually print is defined in terms of some other functions, one of which is putstr. So what we're going to do is this function sends a string to the standard output and terminates it with a new line character. Putstrln just rolls off the tongue, doesn't it? Okay, I think we can actually run this. It's not going to do anything very interesting. I can type stuff. The word was zebra, so I could guess a Z. I could... Wasn't it? Oh. Okay, I can never win here because a win is always false. All right. Yeah. Can't do much testing yet. The program's a bit incomplete. Okay, any questions about the structure of the program so far? So we now need to fill some of this stuff in to make it actually work.